Welcome back, my dear students. In last class we got equation of circle. This is the equation of circle. Means what again it tells, if you know some geometry, if you know something about geometry which you studied in 10th, 11th and 12th standard, then you can say that, sir, this is the equation of circle, and where a comma 0 represents center of the circle, and where r represents radius of the circle. From this a comma 0, I can again understand that this circle, whatever that is drawn by using this equation, that circle's center rests on x-axis always. That rests on x-axis always. Understood? See, then if you see, then what is the center of the wait 1 minute. This characters or otherwise this equation or otherwise this equation, you can say that the circle drawn by using these equations is called as Mohr circle. That is called as Mohr's circle. Interesting, no? Then how to draw that Mohr circle, we'll see. Before that, according to Mohr circle, in the place of x, what is there? In the place of x, sigma theta is there, means normal stress is there. Therefore, according to Mohr circle, normal stress are considered on x-axis. Like that. Here y means here tau theta. Tau, that is a shear stress are considered on y-axis. According to Mohr circle, he got one conclusion, that what should be there in the x-axis, what should be there in the y-axis, because we are drawing graph. Now we got a little clear idea that what should be there in the x-axis, that is the normal stress. In y-axis we should have shear stress. Okay, now next, and Mohr circle, whatever we draw by using this big equation, this represents the center of the Mohr circle will be a comma 0. A means sigma x plus sigma y by 2, comma 0 means this is 0, and radius of the Mohr circle will be what? Go back, see here, square it is. This is r square and this is r square, and this r square equal to this much means what is r equal to? And r equal to square comes this side, therefore that becomes root of sigma x minus sigma y by 2 whole square plus 2 square. This is the radius. Now it is very easy. You got the center and you got the radius. Then by knowing the center and the radius, you can draw the circle. Can you draw? Yes, you can draw the circle, obviously. Say for example, I will give an example. Let us consider I have one problem here. This problem says that this is the problem. Here it is 80 and this is a 40 and this is a 20. If these values are there, then draw Mohr circle. Means center equal to sigma x plus sigma y by 2, comma 0. Therefore, sigma x is how much? 80 plus 40 by 2, comma 0. That is 80 plus 40, 120 by 60, 260, 60, comma 0 is the center. And what about radius? Radius equal to, I will directly write it, sigma x minus sigma y by 2 whole square plus 2 square. Okay, then the answer what I get here is 80 minus 40 is a 40, 40 by 2 is a 20, 20 square plus 20 square, 800. Root of answer is 28.28. 28.28. What I got? I got radius. And what I have to do? Then I have to take a graph. In this graph, this is a normal stress because Mohr already said this is a normal stress. Then this is a 10, 20, 30, 40, 50, 60, 60. This you got 60. 60 comma 0 means this is the center. 60, 70, 80, 90, 100, 110, 120, 130, 140. No, 140, 120, 10, this is 100. Just I'm not wasting much time. Then you got 60. Then what is the radius? Radius is 28.28. Then take a compass. You put a pencil here. You put a pencil here. Here one needle will be there. And this radius you maintain how much? 28.28 you maintain radius. Then this needle you put it on the 60. 28 means 10, 20, 28 will be somewhere here. Then here one mark. Then 10, 20, 20 here. Then you draw one circle. Okay. This is called as Mohr circle. This is called as Mohr circle. Okay, na? But still there are some procedure to draw the Mohr circle, not this procedure. This is a very rough idea to draw the Mohr circle, but there is a standard procedure in examination. They may ask a question saying that how you construct Mohr circle, explain. What is the procedure to construct Mohr circle, explain. In that case you need to write that explanation, not like this. This method what I explained here in this slide, that you can use it when problems are given. When problems are given, you can use it like that. Okay. Next heading will have, that is a construction of Mohr circle. Construction of Mohr circle. Okay, na? For that, here you should see this diagram. In this one, this is the x-axis and this is the y-axis. X-axis is considered direct shear test, direct stress or normal stress, and y-axis is considered shearing stress. Right? That is the toe, positive upwards and negative downwards. And this side we consider it positive and negative will be the other side. Then here just see once we will go through the names. Here O is, this is N and M. This first point and last point is M and N, and here is a A and B, the middle point is a C, and here one E point is there, D point is there, P is there, P point is there, and here S1 and S2 is there, right? Then sigma 2, sigma y, sigma x, sigma 1, and sigma 1 plus sigma 2 by 2, comma 2 max, sigma 1 comma 0, sigma theta to theta, sigma 1 plus sigma 2 by 2, comma 2 max, and sigma y to sigma 2 comma 0. Okay, these all just for your reference, just I read them. And now we'll go how to get this, how to draw the Mohr circle. Okay, which line will be first here, which line will be following to that next here, that we are going to study. This system is called as Cartesian coordinations. Cartesian coordinations will be having x-axis and y-axis. This is a y-axis. We'll consider it as a 2x, as I said. That diagram already shown. This is a normal stress, positive. Okay, this is a positive. Now what we need to do, here the conventional diagram is there. Here stresses are there, sigma x, sigma y, and toe is there and they are acting, and some one plane is there, interested plane making an angle theta with vertical. On that some stresses will be generating, that is a sigma theta and toe theta. Analytically we know the meaning of them, but graphically how to draw them. First what you need to do, this is a normal stress, therefore the normal stress how much it is there, that you need to mark it here. Yes, I marked this one. This is what, this distance is sigma x. Yes, I marked a sigma x value. Then the another one is sigma y value. This sigma y value is also normal stress, therefore it will be somewhere here. And one condition you know already, that sigma x and sigma y, here sigma x will be greater than sigma y, therefore this distance will be sigma y. Distance will be sigma y, you got, right? Okay, now we need to see this tau. This tau we need to see. Look at here, very interesting. This plane is there. I will change the color. See, this plane is there here, vertical plane. This plane is called as vertical plane, or y-axis. This is a vertical plane. On this vertical plane, sigma x is acting. On this vertical plane, tau is acting. But this tau is acting like this way, and his partner will be somewhere here. These two are creating anti-clockwise, therefore that is negative. Means on this vertical plane, sigma x is acting and minus tau is acting, right? Then this is a tau plus tau axis and minus tau axis, minus tau here and sigma x, that point you will get somewhere here. This point indicates what? Sigma x comma minus tau. Like that, if you take this horizontal surface, on that sigma y is acting and one shear is acting. This shear look like this way and his partner is in this direction. Then these two creates a clockwise shear, positive. Therefore on this axis, tau acting plus tau is acting and sigma y is acting. Therefore that will be somewhere here. This is sigma y comma plus tau. Then the procedure says that if it is A and this is the B, and in the diagram it is said this is A and this is B, and this we will call it as a E point and this we will call it as a D point. Okay, then we need to join them. Join E and D. Join E and D. Yes, I joined them. Then wherever it cuts the x-axis, this point you call it as a C. This point you call it as a C. Now from C to E, CE as a radius you consider and complete the circle. CE as the radius, complete the circle, then you will get a Mohr circle this way. Okay, this is a Mohr circle. Just see here, look at here. Yeah, exactly, it is done. First what we did, we marked A point, we marked B point, after that we marked D point, we marked E point, then we joined that and it cut x-axis at C point, we got C. Then C and E as a radius, then we draw a circle. Then wherever that cuts in the y-axis, x-axis, that is a M, and wherever that it cuts in x-axis, that is a N. Just I show here, this is a M and this is a N. Okay, now then after that we'll consider one point P here. There's this P point. One more thing, very important. Before that, this line I want to name. This line, what is this line is called? What is this line is called? Always you remember one note, that the line passing through C, center C, and any point on circumference is called plane, is called as plane. Okay, now see, this is a center point and this is the one point on the circumference, therefore this line is also called as a plane. This is one plane and this is another plane, but we have to name this plane, therefore this sigma y and tau is there here. Sigma y and tau, where is that? Sigma y and plus tau is here, means this is like x-axis, horizontal plane, therefore I will call this as a horizontal plane, or I can say x-axis. This is x-axis, then this will be y-axis or vertical plane. Where it is? Here it is, vertical plane. Okay, that is a y-axis. Then the angle between the x-axis and y-axis here in the Mohr circle is 180 degree, and the angle between the x-axis and y-axis in the conventional diagram is 90 degree. Means whatever the angle you read here theta, when you come to the Mohr circle you need to read it as a 2 theta. Very important, note it down. Whatever the angle you read here theta, that when you come here you need to read it as a 2 theta. Okay, now if I have here angle 25 degree, then when it comes to here, that I have to read 50 degree. 25 into 2, 50 degree I need to read. Then here theta is with respect to what? With respect to y-axis. With respect to y-axis, and that is anti-clockwise direction. The same thing I need to read here, anti-clockwise y-axis. I have to mark that will be here. See, this is the 2 theta. This is a 2 theta, and we are getting here. This point I will call it as a P, and whatever the readings you read, this corresponding reading and this corresponding reading, they are called as sigma theta comma 2 theta values. Now, see, we are not using any empirical derived equation, but directly from the diagram, from the Mohr circle, we got sigma theta and 2 theta value. You need to just read the coordinates of point P. Okay, this is the procedure to construct a Mohr circle. Okay, no? Thank you very much. In the next class we will see mathematical proof for this Mohr circle. Thank you.